I forgot I've had the volume turned down, so we haven't heard that recently. So it's nuclear fusion of hydrogen atoms into helium atoms that is generating the power. Now, the energy was there. It was there in the form of mass. It's being released in the form of electromagnetic waves, light. And we need that light. We need its heat, its energy. It's over 99% of the Earth's energy budget is coming from the sun. So if we didn't have that, we would be popsicles. Just like if we didn't have the greenhouse effect to hold in that heat, we'd be popsicles. We had the distance. How far away is the sun? 93 million miles. And that's why it appears so small. Even though it's out of sight, what does the sun do at night? Still shines. Okay, that's an important one. You probably heard the jokes. We're going to send a spaceship to the sun. Well, how are you going to do that? It's going to make them burn up. Oh, we're going to land at nighttime. The sun shines night and day. Why do we have night then if the sun shines night? You guys all know this. Because we're in the shadow of the earth. Right? The sun is only going to be able to hit one side of the earth. When we're on the side that's in the shadow, the sun's not hitting us. It's dark. So it's a mess. I think that's gigantic. Fused into helium at temperature of millions of degrees. Millions of degrees. The core of the sun is a little bit over 15 million kelvins. That's really, really hot. That's necessary to make fusion occur. Fusion requires two protons to come and hit each other. But what did you learn about charge? Not much, because we didn't cover electricity, did we? But opposites attract and likes repel. So the protons both have a positive charge are going to repel from each other. And so to make them actually come close enough together to interact takes a huge amount of energy, and temperature is proportional to kinetic energy. So as you raise the temperature, you raise the actual kinetic energy, you make those molecules move faster, and unless they have enough energy to collide. So that's why it has to be millions of degrees. That's not a place where we could live without. All right, second song, the whole plasma thing. Everything's a gas. Everything is a gas because they're moving so fast, they have such high temperatures that when they hit, they knock all the electrons off of them, and there's nothing that can hold them together. So you don't have molecules except for in the outer regions of the atmosphere. Everything else inside has no molecules because you have no electrons, which is what makes molecules, right? You have electrons are what caused our bonding. Well, if all the electrons are stripped free, those nuclei are never going to have a bond together. So everything is an ionized gas, which we call a plasma. So I think the song is very information-packed, and it's kind of fun. Looking over the planets. We've already talked about them briefly. We are going to now talk briefly about each one specifically. So in order, remember, you do have to have memorized the order of the planets. Mercury, Venus, Earth, Mars are the four inner ones. Of these planets, do you know which ones have moons? You should all know one for sure. Earth has one moon.
Venus has 7.
Venus has 0.
Doesn't Mars have one? Doesn't Mars have several moons?
Mercury has 0.
Mars has some.
Mars has 2 moons.
Doesn't Earth have 2 moons right now?
Well, as I said, it has a transitory one, a temporary one right now.
Wait, we do?
Yeah.
We can't see it.
No, we can't. It's an asteroid that's co-orbiting with us for, I don't remember how long, a few years.
So those are the names of the moon?
Yes.
Wait, how do they know it's only 3 years?
By mapping its orbit. Its orbit around the sun is such that it has come to our level, and it'll be here for a while, and then it's going to move farther away and leave us. So we have a total of 3 moons, 3 permanent moons, in the inner planets. Not very many. What about atmospheres? Which ones have atmospheres? Earth has an atmosphere.
Mars.
Okay, what can you tell me about Mars' atmosphere?
There's a lot of sun and no oxygen.
It's a very thin atmosphere. When you say a lot of something, it's not a lot, but it is 85% something, carbon dioxide.
Carbon dioxide.
And I think it's 85. It's a large number. It's like 0.15% oxygen.
Mercury does have an atmosphere.
Right. No atmosphere.
And Venus has a very thick atmosphere.
Right.
Yes. I knew it was one or the other, but I was like, gotta remember that.
Jenna, you were literally presented this one.
No, but I didn't learn about this. No, I didn't learn about
No.
this. Oh.
Yeah. All that she was working on was the sun. So we have atmospheres in 3 of these planets, but they're very different. And so those affect the planets. They affect the temperatures, as we had in the homework and went over last class period. Mercury, with no atmosphere, no permanent atmosphere, has nothing to distribute temperatures, and so its temperatures fluctuate quite dramatically. Venus, with its very thick atmosphere, doesn't really have fluctuating temperatures. Earth has fluctuating temperatures. Mars, with its thinner atmosphere, has greater fluctuation temperatures. Hannah has a question.
You answered it.
Excellent.
Is the Earth's moon essential to life on Earth?
No, it's not.
Really?
Oh, so.
But what if we lost it? Wouldn't we orbit the sun differently because we're kind of keeping each other?
We would not have the very minor fluctuation that's going to be measured in miles, a few miles, caused by the moon's orbit. But yeah, that would not. Our actual fluctuation is much bigger than the moon would
So
affect.
if the moon slingshotted out, we wouldn't drop further from the sun.
Now, if it slingshotted out, it would be a little different, but it still wouldn't be huge.
Okay.
But if it slingshot out, you'd have to get a lot of energy to make that happen as well.
If we get to the moon, would it be darker? Because doesn't the moon put out a certain amount of light?
The moon does not put out any light. It does reflect sunlight. And so we would have slightly less light from that reflected light, I suppose. Once again, it wouldn't be anything significant. Okay, so there's some basic facts. Now let's look at Mercury quickly. It is, of course, closest to the sun. It's slightly larger than our moon. Our moon is a big rock. Mercury is a rock that's just slightly bigger than our moon.
Well, Mercury's kind of small then.
It's kind of small indeed. Now, not as small as Pluto,
Yeah.
but it's kind of small.
Is it the smallest planet?
It is the smallest planet because Pluto's not a planet.
Yeah.
We talked about almost no atmosphere, no permanent atmosphere. It does have some ice. How do you have ice? Well, if you have regions that are in craters, then you can have permanent shade and thus permanently cold, and it can be frozen as ice. If you look at its surface, what do you think when you see the surface? What kind of stuff do you see there?
It's scarred.
Scarred. What makes those scars?
Meteorites.
Okay, meteorites. Things that it has no atmosphere, so it doesn't have any meteors, right? There's no such thing as a meteor if there's no atmosphere. If something is on a collision course, it's just going to hit it. Do we know this happens and makes those? Yes, we've seen it occur. So these are signs of collisions. And you have some regions that have a nice, strong, sharp crater. Fairly recent collisions, because over time you do have a certain amount of erosion. Remember, we talked in geology about erosion, weathering. You're going to have some weathering and erosion that occurs even though you don't have a permanent atmosphere. Why? Because anytime we have a meteor shower, we're going through basically some sand that burns up in our atmosphere. Well, what happens if Mercury goes through a cloud of sand? It gets sandblasted, right? Because it hits the surface. And so it's going to have mechanical abrasion on the surface there, and that's what's going to give it some weathering.